One of the more important parts of being a sound designer is to be able to find a way to dig deep into analyzing digital sound. So there are many programs out there which allow for composers or sound artists or musicologists even, people who are interested in discovering what is happening in sound and music to analyze that. So we'll be looking at a type of spectrum analyzer. This is a program which dissects the sound and breaks it down into understanding all the different overtones, the different frequencies that are resonating as part of its spectrum. So when we do that, we can use that for creating the basis for a composition by working on that analysis, or you can use it for musicological or theoretical goals where you want to discover some of the internal patterns that are happening in the sound. So what I have here is a website, sonicvisualizer.org. This is a program, it's a free program for Macintosh, Windows, and Linux that is a spectrum analysis program, but it has many more features to it that can be used for all sorts of applications. It's designed at the Center for Digital Music at Queen Mary, University of London. And these researchers are looking at broadly questions of analysis of sound and audio files for musicologists, for archivists, for signal processing researchers, composers, anybody who would like to find more about what's happening inside the sound of audio files. So you can see here from their site, the opening page gives you information about where the funding for this comes from. Over here, these are important links. There's some great tutorials here. So if you go into the documentation and then take a look here, you will see there's a reference manual, which is really a very thorough manual which takes you through all the different components of that. And then if there are tutorials, if you're looking at specifically for a musicologist guide to Sonic Visualizer, which is many of the applications that people at the Charm Center use as well. But then there's some brief tutorials on individual sections in that. So I suggest as you learn this, take a look at this page because there's quite a bit of resources here. If you click on the reference manual for a second, we would see then this whole list of options which take us through very thoroughly all the different aspects of this program and what it can do. So lots of good information here. The first thing in this tutorial is understanding the difference between panes and layers, which I'll come back to in just a second. So very good tutorial information here. So let's go to the program. When you go to the download page here, if we click on download, then you'll see the options here. You can download the Linux or the Macintosh or the Windows version of this. You can also go for the source code if you prefer. The important part of this program is you will download the Sonic Visualizer application in whatever platform that is appropriate for you. But then the next thing you'll need to do is to download a lot of the analysis and effects plugins. These are in some ways the most important part of this program, which allows us to get involved with certain kind of analysis detail coming from these plugins. So if we go over here, we will see this other category of VAMP plugins. So when you click on this and we open that, we will see this other page which describes what these plugins are doing, so forth, what the VAMP process is. If we click on here, then get some plugins, find links to downloadable VAMP plugins, it takes us to a page where we can now download various VAMP plugins for whichever architecture we have. And I would suggest whichever version platform you're working on, go ahead and download all of these because they will all be useful in giving you flexibility for how to use this program. As you can see, there are quite a few of these. Generally, when you download these, you will install them by copying the plugins, putting them into the files that you download, putting them into various locations on your computer. And you'll see here the various places where you would put those. So for example, I'm using a Macintosh. If I go to the main library folder on the hard drive, open up the audio folder, then the plugins, and then if there's not one already created, create a VAMP plugin, and then just copy all the files into that. And then when you reopen the Sonic Visualizer application, they will all be accessible from that. So it's not that difficult to install them, but this extra step of getting the plugins is important for using this program. So now let's go to the program. Once you've installed the program and you open it up, you will get something like this. This is a blank screen. So you'll see here are the commands at top, which we'll take a survey. Over here, we will have various layers and panes that we can pull up, and then you'll have an output volume here. So the first thing we might want to do is to load in an audio file and sort of see that laid out across our screen here. So obviously there's some standard kind of transport and file functions at the top of here. Plus we can change the function of our cursor from a grab to a select to an edit and so forth. So we'll come back to those. So the first thing would be to load some audio file. I'm going to load one that I've just recently did. This is an audio file of an excerpt of a composition of my own called Sundial, which was a piece written for digital audio with Solo Dancer a few years ago. And this was constructed using a Kima system, primarily were the sounds I used in this, using some granular synthesis kinds of patches. So what I'm going to do is we'll listen to this one, I think it's about 1 minute and 20 seconds. We'll just listen to this, and then I'll take some excerpts from this, and we will try to transform them through going through some of these categories. You'll see here under transform, we can have categories of, these are the effects processors that you put into the VAMP folder. So whatever you put in there will show up in this transform list. So under classification, different kind of similarity features here. If we want to look at the ones that are giving us information about key and tonality, these are the different analysis programs that will affect that. Or we can go under the sort of more low-level features such as amplitude or frequency coefficients, so forth. If we want to try to identify notes in the chord or harmonic changes, information, this would be routines for that. Time, onset, for example, simple percussion onset, which maybe we'll run in just a second, so you can sort of find out where there are beats in the piece, where there are certain kind of energy points that we want to detect. And then different ways of visualizing it through a spectrogram or a chromogram, different kind of tools that are here. You can also access the same ones through just by plugging in name. If you know what it is, you need to get to it quicker. So it's the same list, but just by a different category, or by where these, if you know that it came from a particular maker, such as from Queen Mary, here's the list of ones that they made themselves. So different ways of finding those. So let's listen to the file first, and then we'll apply some of these analysis effects to it. Okay, so the file is a stereo file here. Once again, we can zoom in or out with this button, scroll down here, or we can just click and drag the center down here in the scroll command. We can also, if we want to see more of the amplitude of various spectrums, we can increase the size of that so we can see a little bit more what's happening within the waveform. Maybe if I want to scroll out a little bit more, then let's go back maybe toward the beginning and just pull up only part of this. So if I go back and start at the beginning of this for a second. Okay, I'm just going to randomly select a part of this waveform. So up here we can change to the select tool, and then let's say if we just start dragging about here, select all the way maybe to here, I don't know where that is. And if we want to listen to this loop, just this section, we go up here to the playback. We can now turn on the loop playback and also turn on the constrain playback to selection. You can do this with just the L or the S command on your keyboard. So if we do that, turn that on. So now when I hit play or hit my space bar to hit play, it will just continually loop this section. Okay, so if you want to find out more what's going on inside this section, now let's zoom in a little bit more, and we can sort of hear what, and get that centered. So now if I want to slow it down to hear it more individually, we can keep hitting the slow down. Do it again to even slow it down further. So we're getting a little bit more to understanding what each articulation is sounding like. All right, now let's apply some of the analysis to this to see what we can discover more that's inside here. So one of the first things would be to go to the pane window, and we're looking at the waveform now, but if I want to go to a spectrogram, the spectrogram will analyze obviously the spectrum of each of the sounds and put it into a second chart below that. So when I click on that, we then get to see what are the content of the various spectrum of sounds occurring here. Now on the left side here, we do see the frequency range from 86 hertz, which we're seeing at the bottom, all the way up to 21 on the scale, but we're probably topping out in our spectrum around 18,000 is where this particular recording was. Now you'll notice as I move my mouse over the various spectral points, we do get to see an analysis of what that's pointing to in the spectrum. So we can see what pitch it is, or a small range of where the pitch might be, and then the frequency, then the decibel level of that as well. So you're getting a lot of information here. If I want to maybe scroll into this a little bit tighter, and then pull down to go down to the bottom of the spectrum, now we can see all the way down to 43 hertz, we start to see where the fundamental pitches are. If we just put our mouse over, say, a fundamental like that, we can start to see it's minus 13 dB. It's at a frequency of 215 to 258, and still pretty wide. If I zoom in more, I would be able to isolate that to a closer range. But now we're getting more information. If I wanted to zoom in even further, maybe pull down. So now when I start to look at this particular spectrum here for a moment, I can see all the overtones that are present in that, or all the parts of the spectrum, and I can start to identify where the amplitude and the frequencies are for that, for example. So the spectrogram gives you a lot of information about what is happening inside the waveform that is going to be important for analysis purposes later. Let me kind of continue on with this. So as you get through these analysis forms, you can click the X and that will go away. We could be adding other kinds of panes. I'll let you explore a lot of these. I'm just going to skip around a little bit. If I do the peak frequency spectrogram as next, then I'll get rid of the spectrogram for a second. Let's just look at, this is another analysis of the spectrum, but it shows us where the peaks of which are the loudest partials in the spectrum. So here we start to get a little bit more clear information about exactly what is going on in these various points. And over here we can see a little piano staff, which will help us understand where the pitches and partials are. So if this was close to, looks like an A, is that what it is? No, that looks like a G here. So we've got a G fundamental on the bottom here, but we're not really hearing anything coming out of that point. The closest loudest partial may be starting here around 75 hertz, or if we look up there, we can get a clear indication of where that is. So here, as I put my cursor over certain ones, let me scroll in a little bit more on this. So now we can start to really pinpoint in as to where these markers are, and start to see where the 86 hertz, what pitch it is, the decibel range. So now we're getting much more specific information about where the peaks of the spectrum are occurring. So let's listen to this once again, see if we can. So you can tell where the pitch parts are, where you hear the female voice, and then a lot of the sort of granular noise sound. We can then identify where those, it's a spread of different frequencies that are causing that sort of noise sweep sound that's going through. So we're getting a little bit different picture of what's happening within the sound by doing this kind of analysis. Let's continue on for a second. If I go over to the transform, as I mentioned here, we can get a lot more information about the structure by looking at the transform. And I can close this pane for a second, so we would see information put on top of this in a different layer. If I go down and look for perhaps, can we identify a key on this? Maybe at this point, if it runs a key, we can estimate the key of the music. If there is all that fitting into one particular key, and it gives us sort of the parameters, we can start out with a tuning of A440. So if we click OK, then you start to see here, it quickly analyzes these various sections and see, it says well, excuse me, I'm zooming in. We have right through here something that is an F sharp. It maybe moves up to a G tonality here, and then down to a C sharp minor. So it's estimating whatever pitches are most prevalent there, and then trying to put them into some key relationship. So a very useful kind of understanding for figuring out, is there a particular modulation or a particular relationship of keys in this section. Obviously this section, in my mind when I composed it, was not written with any particular key relationship, but they do group themselves into these sections. So let's listen to this again with that information. So you can hear the C sharp changed keys from the G major here when we added one more pitch into the vocalization there. So it created a different kind of relationship. So that's a very useful tool for figuring out key relationships. So there are many more on here. I will let you do your own in playing through with this. So when you download it, let's go quickly maybe to one of the on the time onsets, for example. If I pick up the simple percussion onset detector, what this is going to do is to try to figure out, are there energy points that would identify beats within this. So we can then set some threshold for that, but let's just leave the default for a second and see what it discovers. And then you'll see here that it identifies peak points and labels them with certain demarcations of where the peak energies were, and there are quite a few on this one, obviously. And then we can start to look at each one individually, the time value they occur, and so forth. But we can also move into another kind of understanding where we do, say, note onsets or tempo, try to figure out, can it detect beats, where the beats are in this, and it will estimate a beat and beat locator. And so it does give us some beats here. And what I like about this one, it does give you a little percussive sound on where it identified beats, and which allows you to sort of add a layer of figuring out where the structures are. So we're getting more information about the rhythmic structure of this particular section. If I continue on into this, for example, and go to see if it can estimate, let's see, let's try another one. Maybe it can do, let's try bars, bar and beat, estimate location, see what it gives us on that. So it didn't really find any bars identified in this category. Let's moving on down to, how about if it does maybe a tempo? Can it tell us tempo on this? So how fast is the tempo moving through? So once we get tempo markings here, we can see. See where it gave us any information there. So you can explore this where there are all sorts of other information. Sometimes it will be able to find that, sometimes not on that. But there are tons of interesting kind of information that you can pull out, extract from these various kinds of tools that you can pull into it. So I would really encourage you to work with this program and to use it for many times for starting a composition. You may want to start a composition where you take another audio file or another musical example use that as the basis for your sound design, but then do extensive analysis on that to pull out information about your tempo, your rhythmic units, key signatures, different kind of timbres that you want to focus on, which you can extract information from the spectrum and then use them in other compositions. And then if you want to analyze other compositions and sort of to see how the composers and other sound designers have put together works, this is a great program for unveiling that. So it's one that I suggest you go through the reference manual and go through all the different units, but it does give you a lot of great tools for doing sound analysis.
The preceding program is copyrighted by Emory University.